Have you ever looked at something and just couldn't trust your own eyes? Well, today we're diving headfirst into that feeling. We're talking about optical illusions. And let me tell you, they're way more than just fun little brain teasers. They are incredible windows into how your brain secretly works, proving that what you see, well, it isn't always what you get.
All right, let's just jump right in. Take a look at this. The circles, they seem to be swirling, right? Kind of pulsing. But I can promise you, this image is 100% static. It is not moving. What you're feeling is your brain, in real time, creating the sensation of motion where there is none. It's a little trick of the light and patterns, firing up your neurons in just the wrong way. So the big question is, how? And more importantly, why does it do that? Let's find out.
You see, to get why illusions work, you have to throw out one big idea. The idea that your eyes are like little video cameras, just recording the world. That's not how it works at all. The truth is, perception isn't a recording. It's an active, non-stop guessing game that your brain is playing.
Think about what your eyes actually do. They take in light, which forms a flat, two-dimensional, kind of blurry image on your retina. From that messy, incomplete picture, your brain has to somehow build the entire 3D world you see around you. That is a huge, huge problem to solve every single millisecond you're awake.
So how does it pull it off? Well, it acts like a detective. It takes the spotty evidence coming in from your eyes, and it combines it with everything you've ever learned to make its best possible guess about what's probably out there. What you think of as reality is really just your brain's #1 hypothesis. Now, you might be thinking, okay, if my brain is doing all this crazy detective work constantly, how does it happen so fast I don't even notice? The answer? It cheats. It uses a brilliant set of mental shortcuts, or rules of thumb, to make sense of all that visual chaos in a split second. A lot of these rules are part of something called Gestalt theory.
Gestalt theory is basically a core part of your brain's visual operating system. And the main idea is actually pretty simple. Your brain is obsessed with finding patterns. It wants to organize all the little bits and pieces it sees into a meaningful, complete whole. It's hardwired to see the forest, not just a bunch of random trees.
Okay, here's a perfect example. What do you see? I get you see 4 vertical columns of dots. But why? None of the dots are actually connected. It's just because they're closer together vertically than they are horizontally. That's it. That's the principle of proximity. Your brain just automatically assumes things that are closer together belong together. Now look at this one. The dots are all spaced out evenly, but you probably don't see columns anymore, do you? Now you see horizontal rows of white dots and pink dots. That's the principle of similarity. Your brain's internal rulebook says, hey, things that look alike, in this case by color, probably go together. It's another one of its automatic sorting tricks.
And this one's my favorite. You see a white triangle, right, pointing up? But look really closely. There is no triangle. There are just 3 little black Pac-Man shapes. Your brain is so determined to find a familiar pattern that it literally fills in the missing lines for you. This probably helped our ancestors spot a tiger hiding in the bushes, even if they could only see parts of it.
Okay, so we've got these amazing shortcuts, proximity, similarity, closure, that help us make sense of the world super fast. But here is the punchline. These incredibly helpful rules are the exact reason we get fooled by illusions. Illusions are basically just predictable bugs in our own mental software. That triangle that isn't there, it's the perfect example. The illusion only works because your brain is trying to be helpful and apply its rule of closure. So in a way, it's not a bug, it's a feature of your brain being exploited. And this whole idea applies to 2 main types of illusions. So scientists usually split illusions into 2 big buckets. You have physiological illusions, like that swirling pattern from the beginning, which are all about overstimulating your eyes. But then you have the really mind-bending ones, cognitive illusions. These have nothing to do with your eyeballs being tired. They're all about the high-level assumptions your brain is making without you even knowing it. And this might be the most famous cognitive illusion of all time, the checker shadow illusion. Now, I want you to look very, very closely at square A and square B. There's no doubt in your mind that B looks way, way lighter than A. I get it, but believe me when I tell you, they are the exact same shade of gray. So what on earth is going on? Well, your brain knows how shadows work. It has a deep, unconscious rule that says things in a shadow are actually lighter than they appear. So when your brain sees that square B is in a shadow, it automatically corrects what it's seeing.
It brightens B up for you. Your brain's assumption about the world is so powerful it literally changes the raw color data your eyes are sending it.
This whole idea that the brain uses its past experiences to change what we see in the present has led to this totally revolutionary way of thinking about perception. It's not just that the brain uses a few shortcuts. It's that the entire act of seeing is an act of prediction.
This is often called the Bayesian brain theory. And it sounds complicated, but the idea is simple. Your perception is always a balance between two things: the raw data coming in from your senses and your brain's pre-existing expectations of what should be there. Your final perception is just your brain's best guess, mixing those two things together. So it works like this, in a constant loop. First, your brain makes a prediction. I think I'm about to see a coffee cup. Then, it compares that prediction to the actual data coming from your eyes. If they don't match, that creates an error signal. Finally, it instantly updates its model based on that error, and that becomes the final perception you actually experience.
And that brings us all the way back around. Because now we can see that illusions aren't just silly tricks. They are perfect, carefully designed experiments that show us the gears of that incredible prediction machine. Illusions are those specific moments when the brain's prediction is wrong, and in getting it wrong, it reveals exactly how it works.
This is exactly why neuroscientists are so obsessed with illusions. They aren't signs that your brain is broken. They're proof that it's working as designed. Every single illusion gives us a clue, a critical insight into the hidden rules and assumptions your brain uses to build your reality, second by second. So if there's one big thing to take away from all this, it's this. Illusions prove, beyond a shadow of a doubt, that what you see is not objective reality. It's not a perfect copy of the world. It never has been.
What you're experiencing right now is an active, dynamic, and incredibly creative interpretation. It's a story about the world, constantly being written and rewritten by your brain. And optical illusions? They're just the really good plot twists. And that kind of leaves us with one last really big thought to chew on. If our most basic sense of sight, of color, of motion, is really just our brain's best guess, it has to make you wonder, what else are we so sure about? What other beliefs, memories, or opinions are also just our brain's best guess? And what else might it be getting wrong?